What is embedding and how the vector space working in the large language model scenario. So let's see. So what is an embedding and what is a vector space? Vector embedding means finding the meaning of data or finding the meaning of a sentence. It could be in any language, it could be in any grammatical format, but when given a one or two or large paragraph, finding the meanings with other words or other sentence with that given within the given context. That really mean by finding the embeddings of that data. Once we finding these meanings, so I will explain this in the next slide, but let's say we find the meanings of data or words in each sentence, then we can draw it in a space that's a high dimensional space. That means it's not two-dimensional, it's not just x and y axis, it's many dimensions. So that's why it's called high dimensional. In a large language model, we may have millions or billions of dimensions. So it's not able to imagine in our mind how it looks like in the real world. But the idea, we need to think that it's having more than two dimensions or it's having n dimensions, and this semantics value then put into this n dimensional database or space, n dimensional space. And when we put this into n dimensional space, it becomes a dense vector. Okay, and I will show you a symbol representation of a dense vector. So this is words which is grouped or classified according to their sentiment label. Positive labels like pretty and attractive and elegant in a green font on this area, but on the negative font, words like dirty, awful, messy as a purple color grouped on here on this space, and the neutral words like impartial, indifferent, independent is placed into this area of the space. And this is a symbol representation. It's not the real representation of the vector space because it's n dimensional. We are showing in a two-dimensional space now. And if you see the theory we learned about the data science video, we see that here the data is grouped into three classes or three levels: positive, negative, and neutral. So the data science model is the basis for this, but there is one more level, which is the position of this data represented in the space. What I mean by position, we can see that all the positive labels or all the positive words are grouped closely as a neighboring words next to next, or it's very closed grouped. And similarly the negative words and also the neutral words. But if you take one positive word and one negative word, we can see that it's not close, it's little bit far away from those two words. So this position is the key when we are putting the words into embedding representation in a vector space. Okay, the data science model will give the classification of the words, and then the vector representation or the embedding, making these words into embed representation in the vector space, give you the distance between these words. That means certain words are having same meanings or same context, while other words, which is, if it is too distant, it doesn't have the common characteristics or common meanings. So that's the whole idea. And we can also think this vector space as a map, as a geographical map in for example Google map, where we have longitude and latitude. So X position and Y position. Similarly, we can find out the embedding points, the real integer values that will denote the real position of a word in this particular space. So we are going to see this in the next slide. What is an embedding model, how it is converting a given text into embeddings in a arithmetics or integer values, and then this integer values is used to position that particular word in the vector space, which having a meaning in the context. So the data could be anything. We learned it in the data science, right? It could be images, text like documents or audio, the voice clips. The embedding model, the data science model, will be able to read this data. Maybe text to speech or speech to text model will be able to get the text value from these audio files, and from the images, image to text will be able to analyze the text representation of that image, and then the embedding model will find the relative position of each word according to other words, and then all these numbers is used to understand what is the position in the vector space. So this is a vector space, and if you see, we can clearly see all the purple color is image input type of data, and all the red color representations are the text type of data, and all the green color the embeddings are the audio type of data. And we can see, depending on their embedding values, okay, these are grouped together. So let's say we have a sentence which talk about cat or apple in image, in document and audio. That will be grouped together in the space, where it will, let's say this part is talking about fruits, and then all the information which is talking about apple will come here, and within this fruits space, apple will be within this small area. Okay, and all the information will be here about the apple. So the similar things or similar context or similar object, similar meaning things will be relatively close enough in the space. But the different objects, for example, in this text, if there is a sentence or there is an image which talk about aeroplane or flying machines, that may be in this space when the embedding is calculated, and this is certainly far away from apple or fruits to the aeroplane or vehicle or flying machines area. Okay, so these are clearly different contexts. So when a large language model is generating a text about fruits, it will get the data from this space, not from this space. So that's the whole idea of this embedding model. And even though it's representing in a this is a 3-dimensional model we are seeing in the picture, but in reality it's million dimensions. So it's don't think about it, but it's that's the core idea about this. Now, since the data point is measured in the position, we can find the meaning of data or different words by its position, or the importance of a data by its position in the vector space. And the spatial properties is used to get the nearest neighbor searches. That means if the large language model uses this particular mechanism, nearest neighbor searches. So if we given a query to the large language model, the query will be transformed into an embedding model and embedding point. And based on that query's embedding position in the vector space, the nearest data points from that area. If the query is landing on this area in the vector space, then the nearest available data points from that vector space is retrieved for generating from the model. Another cool thing or the magic thing about this is it can do arithmetic operations, because the vector space representation is numbers, so it can add, subtract, so that we can find the relative words, the common words, and also the negative words, the synonyms or different negative context of the same topics, the arithmetic operation on the space will allow you to do the positive critics and negative critics on a topic. That's very important, or that's the real magic about this vector space. And this is the another representation to give you a very simple representation of the vector space. So if we able to find out different words from a large number of sentences, and finally the embedding will be able to group things like petroleum, gas and oil into one synonyms, one meanings as a this group. And then in the same vector space we have village, town and country and city in another similarity context which is grouped together. And then emotions like happy and joyful and sad is again grouped together. So if you look into this map, we can see that it's three different contexts. Within the context, the similar words which is having same meaning is grouped together. For example, of this gray, the circle is the in the vector space. This is a logical representation. There is no real representation of such circles, but on this space this is talking about emotions. The context is emotions, and then happy, sad and joyful is the meaningful words within that emotion context. And if we move further into this space of this vector database, this talk about locations, and then village, town, country and city is the meaningful words or semantics words available in this space, and the context is location. Again, if we come to the context, another space in the vector is a different context which is now petroleum or energy and utilities, and within that space we have now petrol, oil and gas. Okay, so this is a quick overview of embedding. The key takeaway is embedding is a data science model by grouping the data. On top of that, it will give you an numerical representation of these data meaning and the context, so that we can plot this in a vector space. And vector space is a high dimensional space, and the position of data in the vector space determines the meaning and importance of data with respect to a context, a given context. The context may be a query given to the large language model. Based on the nearest data point search, the large language model query this vector space and generate the result.